Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the trioxylato cobalt ion complex, and now in this topic we are going to talk about the hexafluoro cobalt ion complex. So what is the structure of that complex? Let me talk about that in this topic. So friends, here we are going to talk about the cobalt complex, and in that case we understand that is the cobalt is the one that has an electronic configuration. That is what we could write it over here as argon 18 3d7 4s2, and we could also write that is 4p0. But here suppose if we have to calculate the oxidation number of cobalt, so in this case it has been found to be that is 3 plus. So therefore suppose if we have to represent the electronic configuration for cobalt 3 plus ion, so in that case the electronic configuration it would be argon 18 and 3 electrons should be lost. So therefore this 2 electrons it will be lost from the 4s orbital, and one of the electron it will be lost from this 3d orbital, and making the 3d to acquire only 6 electrons, while this one will have no electrons, and obviously the 4p will have no electrons. So therefore we could represent the orbital as, I could represent over here, that is for, so friends here we have to fill the number of electrons, so let us fill the electrons. So therefore we have that is 6 electrons in the d orbital, so therefore we would fill it, that is 1 2 3 4 5 and 6. So this is how we have filled the electrons, but the thing is we have to concern with the empty orbitals for the cobalt plus 3 ion. So in this case suppose we understand that is there are 6 ligands, so if 6 ligands has to approach the central metal atom or the central metal ion, in this case that is cobalt 3 plus, so there should be availability of 6 orbitals and 6 empty orbitals especially. So in that case we have 1 2 3 and 4 orbitals only, but we can also write that is 4d0, and we also understand that is the d orbitals it will be vacant, and in that case basically we have now 1 2 3 4 5 6, so we have that is 6 empty orbitals, and that belongs to 1 belongs to s, the 3 belongs to p, and the 2 belongs to d. So therefore the central metal atom it undergoes through an hybridization of sp3d2, and in this case you can see that is there is no pairing of electrons or there is no spin pairing. The reason behind that is because fluorine atoms they are basically strong, that is fluoride ions they are basically weak field ligands, and that's the reason that these electrons are not paired up, and this is what we have basically empty orbitals. And now in this case basically each f or each fluorine ion it will contribute that is 2 electrons so as to form a coordination covalent bond with the metal, and that case it is cobalt. So therefore we have 1 2 3 4 5 and 6 fluorine atoms or fluorine ions that are being associated with the cobalt, and this is how basically we will have that is 12 electrons that could be contributed from the ligands to the central metal ion. In this case it is cobalt 3 plus. So therefore the structure of this complex, that is for this complex it would be nothing but, because it is exhibiting sp3d2 hybridization, so therefore the complex is nothing but octahedral complex, and for that let us draw the structure of it. So in this case the cobalt it will be in the center, it will be surrounded by 6 fluorine atoms as a ligand, as you can see over here, and out of which basically 4 will be on the square, 4 will be on the plane, and that makes a structure that is square planar, but it is not the square planar that is the geometry, it is actually an octahedral. So therefore one of the fluorine it will be above the plane and one of the fluorine it will be below the plane, and this is the structure of that is cobalt F6 3 minus ion, and that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.